Welcome to the Daily MBA, where business wisdom is served fresh and fast, straight from one of the top MBA programs in the world. I'll give you summaries of my lectures and readings, as well as the most important insights gained from an MBA, so you can apply all of this knowledge in every business. Let's get started. In today's episode, I'll continue talking about hypothesis testing, because this is a practice that's widely used in today, and also it's very easy to use because if you have the tools, this is going to be very fast and you just have to interpret the results. Last time, I closed up my episodes by talking about different types of tests. Maybe you could get two-tailed test, or you could also get one-tailed test. I didn't give you an example of a one-tailed test, but basically these are going to be the ones where an alternate hypothesis is going to have a sign of greater than or less than. And so why didn't I give you an example of a one-tailed test? Basically because two-tailed tests are more conservative, meaning that you would need a more extreme value of the test statistics to reject the null hypothesis. And so the default in statistics is always going to be using two-tailed tests. And therefore, most of the packages will always give you two-tailed tests by default. And if you need a one-tailed test, you're going to need to specify it. And also you would need to specify it to the people that you're presenting it to, because people are not expecting to see a one-tailed test. So always use two-tailed tests if you can. And also, there are other things that we should consider, like if the sample mean is larger than the hypothesized population mean, that is not going to be a sufficiently strong reason to use a one-tailed test. So, rule of thumb, you could say always try using two-tailed tests. Literally, one-tailed test would be just complicating things up, and you would just have to explain it extra to the people that you're talking to and to the tool that you're going to use for doing these numbers. So, after we can do all of this hypothesis testing, we can incur in some errors. And we're going to have two types of errors, type 1 error or type 2 error. And this is usually going to be considered as false positives or false negatives. So, let's see how good are you basically at convicting the guilty person. So type 2 error is going to be when you're failing to reject H0, but H0 is actually false. And the type 1 error would be when you reject it, but H0 was actually true. So you are going to be maybe incurring in those type of errors. And so there are some things that we can do for avoiding these errors. Ideally, I want a small probability of both errors. But if we make critical values too big, then some errors might occur. So reducing the significant levels is going to lower the probability of the type 1 error by definition, but it is also going to increase the risk of a type 2 error, because this is going to mean the probability of failing to reject a null hypothesis, which in our case would be acquitting the guilty. So, the type 1 error is going to be convicting an innocent, if we would say, it would be what's considered a false positive, and then the type 2 error would be the false negative. So we're going to have some properties and trade-offs of errors. What I was telling you first was that if you want to reduce the significant level, basically, the bar posts that you had, remember, we're going to reject everything that falls outside of those. These ones are going to go out. And your fail to reject area, which is the one in the middle, is going to expand. So therefore, type 1 error is reduced, but the type 2 error is increased because now you have little space on the other ends. Now, how can we reduce type 2 error? Well, then we would have to increase the sample size, and this is also going to lead the bar post to move out, and the fail to reject area is going to shrink. But everything starts getting more concentrated about the true mean, and this is going to also have another name in statistics. This is going to mean that the power increases. But by increasing the sample size, technically your type 1 error is stable. We're not reducing it, we're not increasing it because we don't change the significance level. We're only going to change type 1 error if we change significance level. So we're always going to find a little bit of a trade-off in these errors. And the only things that you can do are basically think about it intuitively. So if you are reducing the significance level, your fail to reject area, which is in the middle, is going to expand. Then, if you are going to increase the sample size for reducing type 2 error, your fail to reject area is going to shrink, but the sampling distribution are going to be more concentrated around the population mean. So you are going to have trade-offs either way. You want to see which type of error do you want to reduce in specific circumstances. And so as a wrap-up, I'm going to start taking all of the things that we had seen before, which were confidence intervals, and then all of this hypothesis testing and summarize it in this episode now that we know how both of them work. So first, let's go back to confidence intervals. These ones were the estimate of the intervals where you had with some specific probability, which was called the confidence, that this part would have the population mean. And so basically how we calculated were that the confidence interval would equal the sample mean, and to that we would either add or subtract our critical value times the standard error. The sample mean and the standard error would depend on our sample data, but then the critical value would depend on the desired confidence level and the corresponding percentiles of the sampling distribution. Our other method was doing hypothesis testing, and so this one would answer a specific question about the population mean. Or a specific question is going to be our hypothesis, where we're going to put either equal to, different than, greater than, or less than. So here we had 5 steps. The first one was formulating your null hypothesis and alternative hypothesis. Then we would look at the significance level and we would set it. It was usually going to be 5%. Then step 3 would be computing the test statistics, and then you could get either critical value method or p-value method. The lower the p-value, the less likely it is that our sample data could have come from a null hypothesis, so we're going to reject the null when we get a small p-value. So this is going to mean some value that's smaller than 5%. And on the other hand, we're going to reject the null hypothesis when we get a higher value than our critical value. So this one was going to be usually higher than 1.96 or 1.98. So now that I just summarized all of this, basically, what does this mean? Why are we doing all of this? Basically, it's adding points just to get us to know if our results are reliable. Remember that all of this is going to be used in a business context where we want to be estimating how a population will behave. So my example of bank loans is very relevant. Banks do want to know what's going to be the population behavior, but the thing is you can't know the entire population. You only have one sample. So there are going to be 2 ways of knowing if your results are going to be reliable. Our first method is going to be through statistical significance. And so we're going to use the confidence interval and the hypothesis test to be confident about our results. And statistical significance is usually going to be when a p-value is smaller than 0.05. That's going to give you the confidence that your results are actually good. Then, the other thing that we're going to do is controlling for multiple variables. And so this is what I'm going to be talking about in my next episode, because this is going to involve doing regressions analysis. Because here we can identify the different impacts of variables, and we're also going to be getting our best guess, which is going to be our point estimate, hypothesis tests, including our p-value, and confidence intervals. So we're going to start mixing all of the concepts that we've already studied into regressions, which are the most common thing that we're doing with stats in today's world. So be sure to check out the next stats episodes where we're going to start applying all of those weird concepts that I've been explaining in order to understand how regressions work. I'll see you next week.